May 6, 1965, RAF Boscombe Down, Wiltshire. A crowd of test pilots, engineers, and Ministry of Defense officials watches as a ground crew tows the last flying TSR-2 prototype onto the apron. The aircraft is pristine. Its airframe has accumulated fewer than 25 hours of flight time. Its engines are running perfectly after a series of technical problems that were resolved in the final weeks before the program was canceled. The crew that has been working on it for months knows every rivet. They know what it can do. They have watched it accelerate past Mach 1 at low altitude, watched it hold steady at 200 feet above the ground at 600 miles per hour, while lesser aircraft would have been shaking themselves apart. A ground crewman places a wheel chock in front of the nose gear. It is the last maintenance task anyone will ever perform on this aircraft. The cancellation order has already been signed. In the weeks that follow, the British government will not merely retire the TSR-2, it will destroy them. The surviving airframes will be used as ground targets for weapons testing. The manufacturing jigs, the precision tooling that took years to build and would be required to ever produce another, will be broken up. The technical drawings will be locked away. A Labour government minister will later acknowledge that the intent was to ensure the program could never be revived regardless of which party came to power. Britain did not cancel its best aircraft. It executed it. To understand the TSR-2, you need to understand what Britain faced in 1957. The Cold War had produced a specific strategic problem. NATO's Central Front in Germany required aircraft capable of delivering nuclear weapons at low altitude, at high speed, deep into Soviet-controlled territory, below radar coverage in all weather conditions. The RAF's existing Canberra bomber was subsonic, aging, and increasingly vulnerable to Soviet surface-to-air missiles that were improving every year. A replacement was needed urgently. The operational requirement that emerged, OR 343, was extraordinarily demanding. The aircraft had to fly at Mach 2 at high altitude and sustain Mach 1.1 at low altitude below 200 feet, in turbulent conditions that would tear apart conventional airframes. It had to carry a nuclear weapon or a conventional bomb load of up to 2,000 pounds. It had to operate from short, unprepared airstrips, reducing its vulnerability to Soviet first strikes on main air bases. It had to navigate autonomously to a target hundreds of miles inside enemy territory without external radio guidance. In 1957, no aircraft in the world could do all of these things simultaneously. The aircraft that OR 343 described had to be invented from the ground up. The contract went to the British Aircraft Corporation, formed by merging Vickers and English Electric to create a company large enough to handle the program. The airframe that emerged was radical. A high-mounted delta wing with a pronounced anhedral droop on the outer sections to manage low-altitude stability in turbulent air. A variable geometry air intake system feeding two Bristol Siddeley Olympus 22R engines, the same power plant family that would later go into Concorde, producing 33,000 pounds of thrust each. An advanced terrain-following radar system that could map the ground ahead and automatically adjust the aircraft's flight path to maintain a constant height above the terrain at speeds where a pilot's reaction time was physically too slow to be useful. Fly-by-wire control systems that were, in 1963, a decade ahead of anything else flying. a navigation and attack computer integrated across all systems, allowing the crew of 2 to fly the entire mission profile from terrain-following ingress to weapon release with minimal manual input. When the first prototype flew on September 27, 1964, test pilot Roland Beaumont reported that it handled with a precision and responsiveness he had not encountered in any previous aircraft. It was, in the assessment of every test pilot who flew it, exactly what it had been designed to be. The problems were not in the air, they were on the ground. The TSR-2's development had been plagued by the structural dysfunction of the British defense procurement system. 2 competing companies had been forced into an unwilling merger. The Ministry of Aviation had imposed changes to the specification after contracts were signed. The Olympus engines had required extensive development to meet the performance targets, driving costs upward. The terrain-following radar and navigation systems, representing technology that had never been built before, had consumed engineering resources that were difficult to predict in advance. By 1964, the program's estimated cost had risen from the original figure to somewhere between £750 million and £1 billion, a number that produced genuine alarm in the Treasury and provided ammunition to those inside the government who had been skeptical of the program from the beginning. The skeptics had an alternative ready. The United States was offering the General Dynamics F-111, a variable geometry supersonic strike aircraft that the Americans were developing for their own Air Force. Britain could buy it off the shelf, saving the development cost, acquiring a proven airframe, and maintaining interoperability with American forces. The argument was financially compelling on its surface. It was also, as became clear later, substantially dishonest. The F-111's own costs were being actively understated in the figures presented to the British government. The aircraft that Britain was told would cost a fixed price per unit would eventually cost dramatically more. The savings that justified canceling the TSR-2 were largely theoretical. The alternative that replaced it was, by every subsequent measure, more expensive than the aircraft it killed. Dennis Healy, the Defense Secretary who signed the cancellation order on April 6, 1965, made the decision on the basis of Treasury figures that assumed the F-111 would be delivered on schedule and at the quoted price. Neither assumption proved correct. Britain ordered 50 F-111Ks. The order was canceled in 1968 before a single aircraft was delivered, as the costs escalated beyond what the defense budget could absorb. Britain ended up filling the TSR-2's role with a modified version of the existing Buccaneer, a capable aircraft, but one that lacked the TSR-2's performance envelope, its terrain-following capability, and its all-weather navigation system. The RAF flew the Buccaneer until 1994. Every pilot who flew both aircraft said the same thing. The Buccaneer was fine. It was not what the TSR-2 had been. The destruction of the airframes was the decision that moved the TSR-2 story from policy failure to something harder to categorize. Canceling an expensive program is a defensible decision even when the grounds for it are disputed. Governments cancel programs. What happened next was not cancellation. The surviving TSR-2s were used as targets on weapons ranges and for ground fire testing. The manufacturing jigs, representing years of precision engineering, were deliberately broken up. A program officer later testified that explicit instructions had been given to ensure that resuming production would be impossible. The reasoning was that leaving the aircraft and tooling intact would create pressure to restart the program if the F-111 order failed. Since the F-111 order did fail, the reasoning proved correct, and the country that had destroyed the tooling to prevent that pressure found itself without the option it had eliminated. 3 TSR-2s survive today. XR-219, the first prototype, is at the RAF Museum Cosford in Shropshire. XR-220 is at the Imperial War Museum Duxford in Cambridgeshire. A third incomplete airframe is at the Aerospace Bristol Museum. None of them flew after 1965. None of them ever will. The jigs that would have built more were broken up 60 years ago on the instructions of a government that was, at the time, certain it had made the right decision. The F-111 that replaced the TSR-2 order was canceled before delivery. The Buccaneer that filled the gap was retired in 1994. The TSR-2's Olympus engines went into Concorde and flew passengers across the Atlantic for 27 years. The terrain-following technology it pioneered became standard in every subsequent low-level strike aircraft the West produced. The fly-by-wire systems it tested a decade early became the foundation of modern combat aviation. The aircraft that Britain destroyed was not ahead of its time in the sense of being impractical. It was ahead of its time in the sense that the rest of the world spent the next 20 years building the capabilities it had already demonstrated and then discarded. In the spring of 1965, a government minister signed a cancellation order. A ground crew placed a wheel chock in front of the last flying prototype, and a decision was made to ensure that no future government could reverse it. The jigs were broken, the drawings were locked away, the airframes were shot at. Britain did not lose the TSR-2 to enemy action, or to technical failure, or to a rival aircraft that genuinely outperformed it. It lost it to a spreadsheet that turned out to be wrong, and to a deliberate act of institutional destruction designed to make the mistake permanent. 3 aircraft sit in museums. The tooling is gone. The decision cannot be undone. That is not how you cancel a program. That is how you bury one. The TSR-2 story is not unique in its outlines. Defense programs get canceled. Cost overruns happen. Governments make procurement decisions they later regret. What separates the TSR-2 from ordinary program failures is the combination of 3 things happening simultaneously. A technically superior aircraft, canceled on financial grounds that proved to be false, replaced by an alternative that was more expensive and never delivered, and then physically destroyed to prevent any future reconsideration. Each of those 3 elements alone would make for a significant story. Together they constitute something that British aviation historians have been arguing about for 60 years without resolution. The argument will continue because the evidence is unambiguous and the decision is irreversible. The aircraft worked. The replacement did not arrive. The tooling is gone. All 3 of those facts are simultaneously true, and no subsequent government has found a satisfactory way to account for all of them at once. The men who built the TSR-2 were, by the testimony of everyone who worked alongside them, among the most capable aircraft engineers Britain had ever produced. The British Aircraft Corporation team that turned OR-343 from a requirement document into a flying aircraft in 7 years, using technology that did not exist when they started, achieved something that the aviation industry of any other country would have regarded as extraordinary. Their reward was to watch the aircraft they had built be towed to a firing range and shot at. Some of them left the industry entirely. Some went to work on Concorde, which used the engines they had developed. A few emigrated. The institutional knowledge that had produced the TSR-2 dispersed across a decade and was never fully reassembled. Britain built one more major combat aircraft after the TSR-2, the Panavia Tornado, a collaborative European program, because by the time it was needed, no single British company retained the capability to do it alone. The connection between those two facts is not coincidental.